This is a video about how to make a sampling distribution for sample proportions, or p-hat. I'm going to build this example off of the story in 7.56, but I won't do all of the parts. So in the example it says that all 5 major fires in a western desert during one of the recent summers found the following causes. So there was one fire that was arson, one that was accident, one that was accident, one that was arson, and one that was accident. So we know that the population is 5 fires. And what we're going to do is say that we take samples of size 3. So I'm just going to name these fire 1, 2, 3, 4, and 5 so that we see the 5 fires. So what's going to happen, well actually, what's better, let's name them A, B, C, D, and E. That's less confusing. So if we take samples of size 3, first we need to figure out, first thing I'm going to figure out is what is population proportion of fires that are caused by arson. So we see that arson is 2 out of the 5 fires. So we know that the true population proportion is 0.4. The next thing we're going to do is we're going to find the number of samples of size 3. So if samples are size 3, then we need to find the combination of a total of 5 in the population, choose 3 at a time, and figure out how many samples are possible. So this would be 5 factorial over 3 factorial, 5 minus 3 factorial. So we see there's 10 total samples. So now I'm going to create those samples. So if they're size 3, then we're thinking of 3 at a time, 3 fires combined. So I just chose all the fires that would have A and B. The next ones I'm going to choose are the fires that have A and C, and then the fires that are A, D, and E. Next I'm going to do the ones that start with fire B, then B, D, and E. Then I'm going to start with fire C, and now I have 10 fires, or excuse me, 10 samples that each have 3 fires in them, and so that is all the possible samples. So after creating all the possible samples, each sample needs a p-hat, or the proportion of the proportion in that sample that had arson as a cause. So I'm just going to list below here so it's easier to see on the screen. A was arson, fire A was arson, fire B was accident, fire C was accident, fire D was arson, and fire E was accident. So that's the same as what's above, it's just where I can visually see it on the screen. So if I had fire A, B, and C in a sample, this one would be arson, this one would not, and this one would be not. So P hat is, 1 out of the 3 fires is arson. Similarly, doing A, B, and D would make 2 out of the 3 fires arson. A, B, and E would make it 1 out of the 3. A, C, and D would be 2 out of the 3. A, C, and E would be 1 out of the 3. And A, D, and E would be 2 out of the 3. Moving to B, C, and D would be 1 out of 3 are arson. B, C, and E would be 0 out of 3 are arson, and B, D, and E would be 1 out of 3. And then finally, C, D, and E makes 1 out of 3 that are arson. So what this tells us is that's a set of everything that could happen for P hat if we took a sample of size 3 out of that whole population of 5 fires. So the last piece is just making the sampling distribution. The sampling distribution says what are all the P hats that can happen and what would be the probability of getting that P hat if a set of 3 fires was each of those sets or each of those samples are all equally likely. So the first one is it's possible to get 0 for P hat. And there's 1 out of the 10 samples that had that. That was if it was the sample of B, C, and E. Now the next one is a 1 in 3, which comes from several of them. Just to make sure I'm eliminating them all, I can say here's 1, 2, 3, 4, 5, 6 possible samples that would give me 1 out of 3 is arson. The last case is 2 out of 3, which came from 1, 2, 3. 3 of the fires had a 3 of the fires had 2 out of the 3 as arson. And so now I can double check that this is truly a sampling distribution for proportions. It has every P hat that would be possible from that population, and each of them has the probability out of 10 possible samples that could be chosen. And notice this sums to 1, which is a cross-check to make sure it's an accurate or an appropriate PDF, because it has to sum, the probability has to sum to 1.